Okay, so I'm going to do a brief advertisement, really brief, for features coming for how you can use the center's software on the cloud. And it's going to be new ways of using our software on Amazon Web Services, and now being able to view them using a web browser. So I'll give a little background. So Amazon Web Service is a cloud of computers, a large number of network devices that provide software as a service. The trivial way of describing the cloud is someone else's computers, but there's much more to it than that. One thing that's stored on the Amazon cloud is Amazon machine images. These are snapshots of different sorts of machines that can be applied to different sizes of machines. And for our purposes, we can put one together to provide on-demand access to a molecular modeling workstation. And it's possible that yesterday you did some workshop work in the afternoon, some tutorial work that used something very similar, run by a university-based Amazon account. And these services, you can run them yourself. So the idea is anybody with an Amazon account, which is free to get the account, after which you have to pay a few pennies an hour, sometimes dollars an hour, to get a machine. You select the machine image you want, and then you can choose from a range of CPU, GPU, memory, storage. More power equals more dollars per hour for that instance. And the instances it launches are ready to use with software installed, no matter how complicated it is. And it can prove very handy if you don't have local access to a capable workstation, or especially so if you're in a teaching or training situation, if you don't have a classroom full of workstations, or if you don't have a really expensive workstation that has the GPU and memory that you might need. Right, so VMD and NAMD has been available in the past as one of these Amazon machine images, but over about the past year, Amazon security restrictions, they've made them not available, so that new users weren't able to use them. So only people who had been using them, who had already been using them and were comfortable with the increasing security problems that running them in the Amazon cloud and not being properly updated would bring. So now we have new versions of them coming soon to bring back this ability with a little bit extra. They pass the security requirements, and of course they use our recent versions of our software. An advantage of this of these newer images is that you can run this remote session, which is a accelerated graphics remote desktop session, including having your OpenGL graphics accelerated not through a local client, but through a modern web browser. This is just using the latest version of this nice DCV software, which runs on any modern web browser. This is a notable deal for people who are running Macintoshes, because there hasn't been a local client on those for a while. And they just can't run on modern Mac OS operating systems. So a lot of folks are connecting on their Macintoshes to a slower, lower performance version using non-accelerated graphics, which is not as great an experience, especially when exploring a big, complicated graphical system. So the idea of using one of these is a single click in the Amazon Marketplace starts the process, after which you follow brief connection instructions. We have new versions of the AMI with the modern, with our latest software, getting pretty close to this. They need some cleanup, but they're about there. And one nice thing is this this really impressive and exciting new feature from VMD, the RTX real-time ray tracing, RTX real-time ray tracing that I think you saw demoed on Wednesday, works on any on an instance that you purchased with that's NVIDIA equipped, meaning a reasonably modern NVIDIA GPU in the instance that you specify when you start up. If you do that, then you'll be able to do real-time ray tracing. So I'll show a brief proof of existence with a demo unless Chrome has crashed on me like it's been doing lately. Let's see if I get there. So I'm going to stop my presentation software for a second, try to switch to Chrome. Chrome is still running, great. And now we can see in a little Chrome window here, in fact, in a Chrome tab, a link. Oop, and of course, the workstation has decided to sleep. Let's move. So let's wake it up again. So this is a workstation running on the Amazon cloud. And here we have the latest VMD 194A55 running with a pretty nice frame rate. It's a little bit slowed down because I'm going through Zoom now, but this is pretty stunning to be coming through a web browser on my desktop here, which can't do anything like the NVIDIA accelerated real-time ray tracing, not on my Mac at all usually. And I think what's going here is showing off a little bit of the brilliant features that John has added. We have some reflective surfaces. We have some depth of field showing, and well, you could be impressed by this really nice smooth frame rate, except you're seeing this over Zoom, so you're probably not being stunned by this frame rate. But like with other, so this is connecting to one instance, and you can have multiple sessions running on a single instance that you're running. And this is another tab pointing to another machine with another VMD session. Hold on, let me wake this one up again. It's got the same problems of any remote desktop. It's got annoying user interface Chrome. Let me try to get past it. Little tough during a Zoom session. That'll do it. If I'm lucky. Great. And we also, of course, we have NAMD running locally. Let's see. Oops. Yeah, of course. All right. Move over here. Sorry about that. And of course, just as I think we have a, here we go. Yeah, and of course, oops, done. Sorry about that. Sure, I have. I move stuff around to myself. So here is. Sorry. I changed the little proof of concept NAMD file I had in there a few hours ago. There's a million atom system running at reasonable speed using NAMD 2, taking advantage of, I think, the 8 processors this particular instance has. And that's percolating along pretty well. Let me get back to this presentation. So this is coming soon. Get this going. So we've got a page about our cloud offerings here. So watch out for this coming offering there on this cloud page. And I think we'll be sending announcements to VMDL and NAMDL and hopefully our Twitter account, if there's bandwidth on that, when we make these publicly available. So just wanted to get that bit of announcement out and give you a short demo on that. I'd be happy to answer any questions on this. Perhaps no questions? Let me check the interface.
Can you hear me?
Yeah, I can hear you say.
Okay, perfect. One quick question. If we are using another service, another cloud service, except the AWS, what is the solution for running NAMD or NAMD?
Well, we have been doing a good bit of NAMD on Azure, and we've been encountering some good results, but also some troubling results running NAMD on Azure. Here's like a backup slide about running a lot of NAMD on a lot of nodes on Microsoft Azure or Azure. I'm never quite sure how they want that pronounced. And we were seeing for like a 10 million atom system as many as 17 nanoseconds per day. The caution is for really large node runs on Microsoft Azure. We're trying to use Azure as a supercomputer, and reason I'm not, and we're working on having this be predictable and reliable. There's a reason that supercomputing centers employ people to keep their machines healthy. Working with the equivalent of big Slurm clusters made through a system called a Cycle Cloud on Azure leads to, at least for us and for now, a level of problems in node communication between nodes, individual node speed being a little bit unreliable. And so we're in the process of getting together pre-run tools and the package to run before running NAMD, or that kind of runs with NAMD to make that a little bit more foolproof. Some folks in Microsoft can get really good and reliable results running large numbers of Azure nodes with NAMD, and we're working with them to get out a reliable toolkit for running NAMD there. We have seen running, say, single GPU instances on Azure works great, though. The same as running on, say, and that's like, say, running, say, NAMD 3 on Azure GPUs. That works just about the same as running it on a GPU system that you own yourself. And there, that's just and there, that's as simple as downloading the software and running it, pretty much. So we should add to our cloud section maybe some helpful instructions for tweaks to help that to have that run better. So we've got the GPU case running wonderfully, and the large node count CPU case running in a way that needs some support tools right now.
Okay, thank you. Another question is, should I compile the NAMD from scratch, or I can use the precompiled, just easily download and run it?
For yeah, that's for what we'll release for Amazon. You should be able to run fine with the precompiled versions. For on Amazon AWS, the precompiled versions are designed to work really single click. For taking our software and running it on Azure, you want to compile locally, at least for now. The a future goal, once things are at least reliable for large node count CPU, is releasing the equivalent of AWS AMIs for Azure. So that will also be single click. So no and yes are the answers for Microsoft and Azure.
Okay, thank you.
Sure thing.
I also have a question.
Okay.
So I wanted to ask you a little bit more about the practical aspects of using Amazon Web Services. So right now, what are you seeing as kind of your? It looks like you're using the actual web server for the development environment as well. So you're setting up your simulations in the Amazon web server. Are you seeing like a certain amount of cost associated with just kind of like when you're setting this up versus when you're actually running these simulations or setting up these renders?
Yeah, so one big use of it is when you need, so what are the use cases for using these images at all, right? So an easy one I've told you is using large numbers of them, right? If you're going to be doing many months of work, right, following the schedule of like a modeler who's not just trying something out, but staying with it for a long time, those costs will add up. These are hourly costs, and even a few pennies, or in the cases of a really nice machine, $1 or so, if you keep them present and running to do your work, you might encounter $20, $25 a day, and that's going to, even for a really big workstation, start to bite in your budget. This might be for smaller jobs when you want to do some rendering and you don't have access to that to that kind of GPU, or you want to try out the software kind of briefly for just a small project, like for a few days. But if you're really planning to run extensively, you'd start paying a lot of money, I'd say.
Yeah, so I'm kind of envisioning this as something where, like, let's say you're trying to render a really nice image for, you know, a figure for an article, or you're trying to, you know, do something that takes a lot of computer time, like running these molecular dynamics simulations to get these trajectory files. So I'm wondering, what's the best kind of workflow for that? Would you suggest, is it as simple as, you know, downloading the program files and the model files and then going into and uploading them to the cloud, running them through the, you know, desktop environment using the GUIs, or is there a better way where you can basically link your AWS account through the command line and basically say, okay, VMD, run this molecular dynamics simulation using like QuickMD, but do it through the send that file over to the AWS server and have them do the computation, then return it. So that way you're like minimizing the amount of time that you're actually calling that.
I see what you're thinking. I think you're thinking of, say, running locally and then just using the cloud for large scale compute, right? Just like you'd be running it at a supercomputer center or a cluster, right?
Exactly.
Yeah, that's a beautiful vision. That'd be really exciting. And having, you know, it's often a dream to be running on a desktop, right? And then tying everything to a powerful distant cluster. And we even have some means in the past of automatically running stuff on remote clusters. But right now we don't have a product that you know, there's a lot of ways of running remotely. So there's right now, that would be great to supercharge, like, say, your laptop and turn and let you have a really fast QuickMD session for a huge structure, right? For running the dynamics. But generally that's a good vision. But generally, right now, I think most folks are manually moving the files over, which is usually a bit of a big deal. So there's not automatic copying of large files, because that can take a big time. And then having multiple phases of the work. So they'll get to a certain point on their workstation, and then if they're going to do, say, supercomputer work, they'll move it over to the supercomputer and do work there. What's a role for remote visualization is that you don't have to download everything in the middle of your, let's say you get a supercomputer trajectory out or a cluster trajectory out while something's living either on the cloud or on the supercomputer. then you can use this remote visualization to do the analysis work where the data is. And that can be helpful no matter where you're doing the analysis, supercomputer or Amazon. If you're running the remote visualization, then it's already in the right place to see your data. So you don't have to take the extra time moving it from where the large data has been made and then dragging it all back. There are there's different personal workflows. A common one is running for a while, making a greatly strided version of your trajectory, and then bringing it back locally for interactive viewing. You'd need to do that less if you have everything running on Amazon. But really, for long time use, I'm thinking if someone doesn't have the money for months of paying for Amazon Web Service fees, you'd use these interactive modes kind of sporadically, just for days at a time. So I like your idea of remotely connecting. That sounds good, and that might be something we work on in the future.
Yeah,
Dave. Yeah. Dave, did you have a comment on this?
Yeah, I did. There was a question about the codes, whether you could use the pre-compiled builds of our software on Azure, I think was perhaps part of that question. But I can't speak to VMD, but I can tell you that we were able to take our NAMD pre-compiled alpha releases, so the GPU resident NAMD 3 alpha releases, and actually use those pre-compiled builds directly on the Azure nodes, and those worked okay.
These were the single GPU?
These were single GPU.
Yeah.
So there were some issues with scaling the multi-GPU runs. The multi-GPU runs require these tightly coupled GPUs. And so if you need GPUs that are at least peered, and it scales a lot better if they are actually directly NV-linked with each other. We didn't have on their V100 boxes, which were I think 8-way boxes. We didn't have these mutually NV-linked GPUs, so we couldn't run we couldn't scale the multi-GPU version across all 8 GPUs on a single node for the V100 stuff. I think the newer A100 nodes are all mutually NV-linked together. I think that's running with like an NV switch. So I think those will actually scale up to all 8 nodes. And if that's the case with their hardware, then the pre-compiled builds that we provide should work out of the box for that.
Oh, really good. Thanks, Dave.
Mm-hmm.
Oh,
yep.
Yeah, and by the way, and a short response to that is, that's a great vision. We don't do it. We have often avoided doing the automatic remote start a job somewhere else bit, because there's so much change happening in all the supercomputer centers year over year. There's just no percentage in it, and changing every time. But Amazon and Azure and a couple of other services are reasonably solid enough and so large that it makes more sense for them. So good idea. Any other questions? Let me check this. And there's nothing here in chat. I've not been looking in chat, Mariano. So let me see.
Okay, another question. Sorry to interrupt you.
Yeah, sure.
What is the benefit of the browser, like what you showed us before in the browser when you open the web server, VMD, NAMD, blah, blah. What is the benefit of this mode over the like installing X2Go or VNC on the instance or a server?
Oh, I'm sorry if I didn't make that clear. Yeah, sorry. This gives you clever acceleration of all the OpenGL windows. So they'll go nice and smoothly. This wasn't really captured in the over this Zoom session, but what's nice about NiceDCV is that all of those OpenGL windows, which will be big, complicated windows that you want rendered, often as a molecular modeler, you want very good interaction as you're wiggling your fingers and looking at something and cheating your eyeballs around something. You want that to be a really good frame rate, and you want it to be sharp, look good. So what NiceDCV does, it does I think hardware assisted compression to compress these figures, these OpenGL windows, all the OpenGL windows, but obviously in this case the main VMD OpenGL window counts among those, and gives you and then the browser, it's easier for things to do the decode than the encode for image compression, and the browser decompresses what it gets back on that stream, and you get much faster and much more beautiful, or rather much more detailed and precise OpenGL windows than you would otherwise for the same amount of bandwidth. And since not everybody has, a 50 megabit connection, this makes a real difference for remote users. So it will look big and fast to people. Even it provides a desktop workstation experience without being at the desktop and without having to have a very, very good and very broad, very wide network connection.
Okay, perfect. Thank you.
Sure. Okay, and I think that's all I see in comments. So if that's it, yeah, I'll say thanks much.